Hello, my name is Dylan Gallent. This is my solution for coding problem set 5, ciphers. So, very first thing we need to do is go ahead and look at the problem we have here. So what we are doing is creating a bunch of different methods that are all going to work together so that we can create our own cipher alphabets, assign those cipher alphabets, and use them to decrypt just basic text and full-on messages. So the first thing that we needed to code was the build shift dictionary, which uses self and shift. The shift is just however many letters we are shifting down the alphabet. So how I did this was I created a lowercase alphabet using string to ASCII as well as an uppercase alphabet, and then I created a shifted lower and a shifted upper, which right here uses that lowercase alphabet and then does it by the shift down and then adds the shift afterwards so that it wraps around. So that creates 4 separate alphabets. Then in here we create our dictionary. We use the dictionary function. We zip them together, the lower and the shifted lower. We zip those two together so that they are associated with one another. So if I put in an A over here, if my shift is 3, it would give me a D over here. Then we update it with the uppercase letters as well, zip those together, and then return that dictionary. By the way, these right here are just to remind me of which functions I coded versus the ones that were already here. So next we need to apply the shift. Well, first off, of course, we need to use the build shift dict that we just used, or that we just wrote, to create our cipher alphabet right here. We're going to create a new message because we need to output something, but right now it's going to be empty. Then we're going to look at every character in the message text, because right here it says we are going to get self.message text and run it through our cipher and output a different message based off of however much shift it gave us. So for every character in the message text, we're going to check if the character is in the cipher alphabet, and if it is, we're going to add to our new message whatever is in the cipher alphabet at the whichever one is associated with the character that we're currently looking at. The reason we do the if and the else right here, this else would just return the character, whatever it is, it would just add it to the new message without running it through the cipher, because this accounts for spaces, periods, exclamation points, anything like that that wouldn't be in the alphabet, but could be in the message. Once all that's run through, we just simply return it. Next, we're looking at a new class, which is our plain text message class. First, we just had to do the init definition. So we just did message.init and then self.shift equals shift. Right here, our encrypting dictionary, we once again use our build shift dictionary, which we coded up there. And then message text encrypted, whatever we've encrypted. Once we've put it through the dictionary, or put it through our apply shift function that we just wrote here. Next couple are pretty easy. We just do get shift, which returns self.shift, get encrypting dictionary, which we do by making a copy of it, safely copying it. Once again, just self.message text encrypted, we're just returning it. And then right here, basically what this is just like the init file, or the init definition. We're just making it so that we can update it at any time without creating a whole new message. Our next class is the cipher text message. Once again, creating an init, just like this, nice and easy. And then we get into one of our main parts here, which is decrypting our message. So how this works is we are given a story text, which is completely encrypted. We are going to run through it to figure out, we don't know which shift it is. We have to try all the different shifts, figure out which shift it is, and then output the code and make sure that we found the correct shift. And how we do that is by just checking every single shift, and whichever shift gives us the most actual words in the English language, which is what we use our word text file for over here. Whichever one gives us the most words, then we return that one, because we know that is the one that the message is actually supposed to be. So if we, for example, ran through and happened to get a couple words just by coincidence, we know that, oh, well, 3 of these words happen to be words in the English language, but the rest is complete nonsense. We know that that's still not the correct shift. So how we did that is I created 3 little variables right here: max valid words, which we'll use in a second; best shift, which is to make sure, how many, what's the best possible shift; and then decrypted message, which is just empty for now. So for the shift in the range of 26, because 26 characters in the alphabet, we go ahead and create our shifted message right here, which is using the apply shift up that we wrote earlier, which we would just use with whatever number we happen to be on in between 0 and 25. Words right here is we just take the message that we have just encrypted or decrypted. In this case, we take the message that we are hopefully decrypting and turn it into, we split it, which turns it into individual words rather than just one long string. And then our valid word count, we take the sum of is each word a valid word in the word for word in words, which is right here. We look through all of the words, individual words that were in the shifted message, and add up how many of them happen to be actual words in our words.txt file. Then we go in and say if the valid word count right here, whatever number of words we just found, happens to be bigger than the max valid words, which of course the first time would just be bigger than 0, we set it to the max. This is going to be our new best shift. We know this is the shift that we like, and then our decrypted message is now going to be equal to our shifted message. Of course, we can run back through, and if this happens to be it happens to just get 3 words, then it runs through and gets 7 words. Oh, cool, we'll save that one instead. And then all of a sudden it runs through and gets however many words happen to be in the actual text, which I don't know off the top of my head. We're just going to say there's 100. If it happens to be 100, then we know, oh, well, that's every single word. We know every single word is in there. Let's run it. Right here, this was given to us. We just check to see if our functions are working. The get message text encrypted function and the decrypt message function. Make sure both of those are working, which they are, as you can see right here and right here. And then right here we do ciphertext 2, which is our use our ciphertext message, get story string, which was provided up right here, which just pulls the story text file. And then we run it through ciphertext, we go ahead and run it through our decrypt message right here, and the output gives us this text right here. And of course the original story text, is just complete gibberish. And right here, Jack Flory is a mythical character created on the spur of a moment to help cover yada yada yada. All of these are valid English words. We know that this was the one we were looking for, and it happened to be a shift of 16. Thank you very much.